All right, let's take a look here at lesson 5, writing equations in slope-intercept form. So what we're going to be doing is we're going to be looking at graphs and different things and trying to write the actual equation that goes with that line. So first things first, let's determine the equation of the line whose graph is shown here. All right, so how do we even start with this? Let's see. One idea is to look for some of those key components that we know are in the equation of a line. So in the slope-intercept form, right, because that's what we want to try to write it as, we know the slope-intercept form is this: y equals mx plus b, where b is the y-intercept and m is the slope. Well, I would say that we could probably determine these two things by looking at the picture. For example, what is the y-intercept in this graph over here? Well, I find the y-axis and I find where our line intersects it, and it is right there. So the y value where this line intersects that axis is -1. So I know that the b is -1. Now to find the slope, I need to have 2 points, right? Because it's the rate of change. It's how this line is changing over time, right? So let's take a look at another point maybe over here on the graph. And how is the slope changing? It's going up 1, remember rise over run, and to the left 3. So up 1, left 3. Let's just double check and make sure it does it again. Up 1 and left 3. Sure does. And maybe one more time. Up 1, left 3. And it sure does. So that seems to be the continuous idea here for the slope. So what would be up 1, left 3? Some things to think about. The slope is going to be, we know the up is going to be this 1. Now, we know that we're going to the left 3. Some things to think about here is that this line, remember going from left to right, is going down. That's a negative correlation. Remember again with scatter plots we saw this. When the line is going in that direction, it's what we call a negative correlation, which means we have a negative slope. So I went up 1 and ran 3, so the run is 3, but this whole thing needs to be negative. So what we tend to do is we put the negative in the top, because having a negative denominator doesn't make a whole lot of sense. So we're going to put the negative up top, and we're going to call this the slope -1/3. Now all I have to do is take and I plug these things into the equation that I had earlier. So y equals, and it's going to say -1/3 x plus a -1. Or you could say -1/3 x minus 1. That's the same thing. Like that. Okay, so that's the equation of this line. So now it's asking us to find f of 3. Remember, that's how you pronounce this. That's how you say this. F of 3. It does not mean multiply. It is the function evaluated at 3. So in other words, when x is 3, what is the y value, is what this is saying. Right? When x is 3, what is the y value? So when x is 3, what is the y value? We'll see it written like this: f of 3 equals, now let's look at our equation from earlier. We had -1/3. I'm going to leave that x out for a minute, and I have -1. Remember, this is what goes in for x. So -1/3 times 3, all -1. So when I solve this, I have -1 times 3 is -3. -3 divided by 3 is going to be a -1. And a -1 minus 1 is going to be -2. So you could do that in your calculator if you want. Now let's double check and make sure that that's true. So what again was I doing? When x is 3, what is the y value? So let me go to where x is 3. 1, 2, 3. X is 3 right here. What is the y value? It is -2, exactly. So we did a good job there. All right. So now let's test this equation using x equals 3. In other words, let's just plug something in. So you know what? We just did x equals 3. Why don't we try x equals negative 6. Let's try x equals negative 6 instead. So, y equals negative 1/3, and I'm going to plug this in for x, so times negative 6, and then my b value is minus 1. So this tells me I have y equals negative 1 times negative 6 is a positive 6 over 3 minus 1. 6 over 3 is 2, so y equals 2 minus 1, which equals 1. So in other words, when x is negative 6, y is 1. There's my point. So let's see if that's true. Let's go over to negative 6. 1, 2, 3, 4, 5, 6. And my y value, as I go up, come across, it's 1. Okay, so at negative 6, the value of y is 1. You could have written this as f of negative 6 if you wanted to. Okay, it's the same, that just says when x is negative 6. So let's figure out how to find an equation using points. All right, so this gets a little bit tricky. There's a few steps along the way. First thing we have to remember is if we have 2 points, we definitely have a line. You can connect any 2 points together and you have a line. So we know that there's going to be a line. Now it's just a matter of how do we determine its equation, right? Well, the first thing we want to do is we want to find the slope. And I can easily find the slope if I remember that the slope is the change in y's over the change in x's. So why don't I go ahead and label. Remember when we have the change in y's over change in x's, that meant I have y1 minus y2 over x1 minus x2. Okay? And so let's go ahead and label these points over here. So I'll label this first point as x1 and y1. And then I'm going to label the second one as x2 and y2. Right? xy, xy. Okay, so let me plug these numbers in now. y1 is 5, so I'm going to put 5 minus, and y2 is 17. So let me put a 17 here. And then I have x1. x1 is 2. And I'm going to say minus, and x2 is 5. Okay, all of these numbers just correspond exactly to how I labeled them right here. All right, so 5 minus 17, that's going to be negative 12. Let me write it, I'll come down here. So 5 minus 17 is negative 12, and 2 minus 5 is negative 3. I can clean this up a little bit. Negative 12 divided by negative 3, that tells me that is actually 4. Negative divided by negative is positive, but I want to keep it as a fraction, remember, because we're talking about slope, and the way I do that is by putting it over 1. So slope here is going to be 4 over 1. All right, so now what do I do with that? Well, I know a piece of this, right? So remember, I'm going after the point slope slope-intercept form of a line. So we have y equals mx plus b, and I just found the m. Okay, so right now I'm looking at y equals 4 over 1x plus b. I still need to find that b. The nice thing about finding that b is I already have 2 points. I have an x and a y. I have 2 different x's and 2 different y's. Okay, so all I need to do is plug in either one of those points to this equation that I just started to make here, and then solve it for b. And it'll tell me what my y-intercept is. So what do I mean by that? Well, let me start again with that equation. So y equals 4 over 1x plus b. All right, so let's use that point that was 2 comma 5. Let's use that one. So remember, this is my x and this is my y. So all I'm going to do is make some substitutions. Okay, I'm going to substitute the 5 in where I see a y, and I'm going to substitute the 2 in where I see an x. Leave everything else the same. Notice the only thing left now is the b. So that's what I can solve for. I can figure out the rest of this and it'll tell me what b is. So I want this to now say b equals. And the way I make this say b equals is to start, I say 5 equals this 4 times 2 over 1. That's 8 plus b. I'm going to subtract 8, and that tells me negative 3 equals b. Alright, so now I know what the b is, okay? So I found my m, and now I found my b, right? The b is negative 3. So if I know m, and I know b, then I know that y equals 4 over 1, that's my m, x plus a negative 3. Or again, you can write it as just minus 3. Okay, so what did I do here? Let's see. This is actually this last step down here, putting it into that form. Okay, well, what did I do? I first used the 2 points to find the slope of the line. Right there. That's the slope. Then I used the slope and a point to solve for b. Okay? I took one of those 2 points that was given to me, I just used the x and the y values and plugged them in for the x and the y, and I solved for b. Okay, so there's 2 steps to doing this. And then finally, the very last thing you want to do is make sure you put it into the form. Alright, so how does this fit into the real world? Well, if a truck is traveling on a straight road after 2 hours, the truck, not car, is 136 miles from Syracuse. After 5 hours, that truck is 340 miles from Syracuse. Determine an equation for the distance d the truck is from Syracuse after h hours if the relationship between d and h is linear. Alright, so what do we know here? We know that after 2 hours, the truck is 136 miles. Okay, so let's make some stuff let's write down some things we know in this problem here. So 136 miles in 2 hours. Okay, after 5 hours, it's 340 miles. So I know that after 340 miles, we have gone, for 340 miles, it took us 5 hours. Okay, so this is some of the important information, and what we're looking for is to create a relationship between d and h, so the distance and the hours. Okay, so hours is time and distance, right? So many times we have that d is equal to the rate times time kind of thing here. Alright, so a couple different ways we could approach this problem is, first of all, we could create a table if we wanted to, and we could create a table of values to try and figure out exactly how many, like 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, get a whole bunch of points, and then graph those points. Okay, or what we could do is we could look at these as points, distance versus time, okay, where time is our x-axis and distance would be our y-axis. If that was the case, then I would have points here. I could show the relationship. I could say 2, 136, and this one would be 5, 340. And these are 2 different points. So what would be the advantage of doing this? Well, if I had these 2 points, then could I come up with the slope of the line, or the rate at which this truck is traveling? And the answer is yeah. So if I, again, label these x1 and y1, and then x2 and y2, I can now use the slope formula. So slope, m equals y1, the change in y's, over the change in x's. So y1 is 136 and y2 is 340. And x1 is 2 and x2 is 5. So 136 minus 340 is going to give me a negative 204. And that's going to be over negative 3. And I know a negative divided by a negative is a positive. And that looks like that's going to be a positive 68. And we'll keep it as slope, so we'll keep it as a fraction. Positive 68 over 1. Okay, so we just came up with the slope for this equation of a line. So now what can we do? Well, we can figure out what the y-intercept was, right? Remember, we're going after this y equals mx plus b form. Okay, except in this case, it's going to be something like the distance is going to equal m times the hours plus b. Okay, so distance and hours. So it's the same. So it's our independent and our dependent. Independent is h and the dependent is d. All right, either way, I needed to find the slope and the intercept here. So let's use one of these points and plug it in and see what happens. So the distance of 136 miles, and the slope here is 68 over 1. And the hours, I'm using this point here, 136 miles in 2 hours. So that's going to be 2 hours for the time. And I don't know the y-intercept. And let's see what happens here. 136 equals 68 times 2. So 136 equals 68 times 2 is 136 plus b. So subtracting 136 tells me 0 equals b. In other words, the y-intercept is at the origin. It's at 0. Okay? So now I know that the y-intercept is 0, and I can go back and put this into the y equals mx plus b, or this d equals mh plus b form. And so what do we have here? We have the distance is equal to the slope, this part, so 68 over 1, times the amount of hours, so times h. And I could say plus 0 if I want, but that's a little silly. I don't need to put that there. Plus b, since b is 0, I'll just leave that off. So now I've created an equation for this real-world situation. So for every hour I travel, I go another 68 miles, is basically what this says. All right, so that's really all. We will work more with this again tomorrow, and the day after that, and the day after that. We'll just keep seeing this stuff over and over and over again. So if you had any problems with this today, go back and rewatch the video. And try to follow along as best you can. There are certainly other ways you could have done this problem right here that we're looking at, this real-world application problem. This is just one way to do it. I was trying to stay consistent with the way we were doing things throughout this lesson. If you saw a different way, that is totally fine. In fact, why don't you try to write it in a different way and bring it in tomorrow so that we could all see a different way that you could have thought about getting the solution to this problem. All right, well, good luck, and I will see you tomorrow.